This work presents both a dataset and a socially aware trajectory prediction algorithm for aircraft in a non-towered terminal airspace. This is the first 3D social aerial navigation dataset, and our network combines state-of-the-art modules in social navigation to provide predictions in a static environment with a dynamic context. Autonomy in the airspace is important for both commercial and general aircraft and will lead to better safety, address the limited supply of pilots, and reduce costs for flights. An important part of a pilot's job is to plan socially compliant trajectories by anticipating the motion of other agents to ensure mission safety. This challenge is more pronounced in non-towered airspace, around airports where ATC is not present to coordinate between agents. Out of the 20,000 airports in the US, only 4% are towered airports. Our dataset, TrajAir, is collected at the Pittsburgh-Butler Regional Airport and contains 111 days of data spanning several months. The trajectory data is collected from an ADS-B transponder placed within the airport premises that receives data directly broadcasted by aircraft. Weather data is obtained post hoc using the METAR generated by the automated weather observing system at the airport. The data is then cleaned and processed for ease of use in line with current social navigation datasets. We propose TrajAirNet for aircraft trajectory prediction in a static environment with a dynamic context. The model uses temporal convolutional networks to encode the 3D trajectories. The dynamic weather context that includes wind vectors are encoded using convolutional networks, which are appended to the encoded trajectories. To encode the social context, we use a graph attention network to combine data from different agents. Finally, we use conditional variational autoencoders to produce multi-future aircraft trajectories for all agents. The proposed method provides us with the ability to condition the prediction on the ego agent's absolute position history in the static environment. We also condition the prediction on the absolute position of other agents within the terminal airspace, which are weighted according to their relative importance to the ego agent, along with environmental contexts like wind. The network has the ability to predict multi-future trajectories of all the agents. Here we can see the results of the network predicting the future trajectory of the aircraft. The green shows the observed trajectory, red shows the ground truth, and cyan shows the predicted samples from TrajAirNet. Evaluations were carried out on 4 sets of 7 consecutive days of data from different months. When comparing our method to other baselines, TrajAirNet had the lowest average displacement error and final displacement error for all testing sets. We hope this work is the first step to opening the domain of aviation for social navigation.